to view. And we're going to talk about growth and decay. And a lot of this might relate to some things that you have done in science, which I find to be kind of nice that the world of math and the world of science overlap quite a bit with the types of problems that we look at. Probably more in like the chemistry world is where you maybe have seen these problems, or physical science. I don't really remember. But we are going to go through a kind of a generic description of something, and we're going to go through the calculus one time. And after we go through the calculus one time, we know it's going to be the same calculus every time. So if we can get through this right here, we'll have a formula based on calculus that we can use. Okay? So the rate of change of the quantity is directly proportional to the quantity itself. So the rate of change of a quantity, that is describing its derivative. So here I have dy dt. Because we're talking about things changing over time, we're talking about more of, like a real life application here. So instead of x, we have t. Is that okay with everyone? Okay. And when we talk about something being directly proportional, that means we're multiplying by some sort of constant. Okay. Constant with a k. And it says directly proportional to the quantity itself. So if we have dy dt, then the quantity that is changing is y. So the rate of change of the quantity is directly proportional to the quantity itself would mean that dy dt equals y times some constant k. So what we are going to do is we are going to solve this differential equation. Okay? And we're going to see what we come up with. So let's separate our variables. What do we need to do with y? What? Okay. So we need to separate our variables, right? So what do we need to do with y? Divide it over. So we have 1 over y dy is going to equal, remember I asked you to keep any coefficient with the x's, but instead of x's right now we're going to be using t's. Okay, so 1 over y dy equals k dt. So now if we take the integral, we will have the natural log of y equals, what would the antiderivative of k be equal to? Kt. Oh, what did I forget? Plus c. Okay. Then what do we need to do? What? We need to get y by itself by throwing what up there? We need some e's up here so that they can cancel out with the natural log. Okay, and we have that scenario again, right? Where we have e to a power that's being added. And since our power is being added, we know that we can separate that into a multiplication problem where we keep the bases the same. And since e to the c is still going to be a constant, we can just write it as c. Okay. Y equals c e to the kt. And that, ladies and gentlemen, is what you are going to use every single time you see this phrase. The rate of change of the quantity is directly proportional to the quantity itself. Instead of having to solve that differential equation every single time, you can remember y equals c e to the kt. What does it look like? Well, that is true. Does it look like something that we did back in Algebra 2? PERT. That's exactly PERT. Okay? This is where PERT comes from. Okay? Okay? Okay, so let's talk about what these letters represent. Okay? T is always going to represent time. And Y is going to be the quantity, okay? It could be kilograms. It could be pounds. I don't know. It could be a lot of different things. It just depends on the problem, but it's the amount, okay? Now, K is going to typically act as a rate. So if K is positive, then you have something that is growing. If K is negative, you have something that is decaying. Okay, and it will be a decimal because it's going to be a rate of some kind. And then C, if you plug in 0 for T, what would you be left with? C. We would have e to the 0 is 1, and so you'd be left with C. So this C is going to represent the initial amount of whatever you're working with. Sometimes we'll know that, sometimes we have to solve for it, okay? But really, the math that we do from here on out is all of the math that you did both in Algebra 2 and in Pre-Calc when you did your exponential sections, okay? So at least the math should look familiar, okay? And we only had to do the calculus once, okay? So we have 3 examples. That's it. 3 examples that I want to get through before I send you on your way with your homework. What?
We have 20 minutes.
20 minutes to tip off.
But we don't have 20 minutes until the end of class. So the faster we can get through this, the better, right?
Yes.
Correct.
Okay. So read example number 1 for me. Okay. So I hear people talking about this first sentence right here. The rate of change of y is proportional to y. That means the dy dt equals ky. And Turner, if we have dy dt equals ky, then that implies yes. Okay, our calculus is done. In a blink of an eye. Now we just got to do algebra. So when t is 0, y is 2. Okay. How does that help us? Okay, well we know that c is 2. Okay. Now that we know that c is 2, we can use this second piece of information to help us find out the k value. So now we know that y equals 2 e to the kt. So now we can plug in 4 for y and 2 for t. Okay. Well, if we solve for this, we would have 2 equals e to the 2k, right? And if we do our exponential magic, we just rearrange. This is log base e of 2 equals 2k. Yeah?
Yeah.
Okay. So k is the natural log of 2 over 2. Or a It does. So yeah, you can have your calculator out. Could somebody please give me what the natural log of 2 over 2 is?
I got 0.347.
Could you go ahead and give me 6 decimal places here? Mm-hmm.
0.34654.
Why would I ask him to give me more decimal places than usual? Because we're going to have to use it again. Okay, so you can either keep it as the natural log of 2, or you can round to more decimal places. All right? Now, we have y equals 2 e to the k t. And overall, we really want to know what the value is when t equals 3. So what I need you to do is go ahead and plug in to this equation t equals 3. So you can type that back into your calculator. You can use second answer to recall the natural log of 2 over 2 value. You can type in natural log of 2 over 2. There's a lot of ways that you can use your calculator to help you. But if you've already punched in the natural log of 2 divided by 2, then you could recall that number back into what you're plugging in next, instead of having to type it in again.
Then how many decimal places do you want?
The final answer, always 3. Which would be what, Anna?
Yeah. 5.657. Please just
Okay. That was a fairly straightforward problem to kind of get our minds wrapped around what we're going to be doing. What was nice about this problem? What did they give us? What given information was helpful? Okay, and they'll give us that so we know to use it. Yeah. Which point was really nice? Okay, they gave us the initial coordinate, which really helps the flow of this problem. If we're given like t equals 1 and t equals 2, then we have to do a lot more algebra, and I'll show you what that will look like. Okay? But we at least have the basics down. Let's go ahead and flip it over and read example 2, please.
Don't you not have to use calculus for this?
No, we're using the y equals c e to the kt. That's the only calculus we're doing.
Oh, like you just do the chart at 10. And it just goes down by half.
It doesn't go down a half, the half-life. So it takes 24,360 years for it to decay to half-life.
Yeah.
Do you have like some magical thing that you try to do? Is that okay? The math that we do is going to be the same as probably what you did in your chart. Okay. All right. So we are talking. They didn't even like give us the dy dt equals ky, did they? We just know that this is growing or decaying. In this case, decaying, right? We're talking about a half-life. So anytime we're talking about half-life, we're talking about exponential growth or decay, right? But since it's half-life, decay. So we don't even have to do any calculus, which, I mean, you won't have to do calculus in your homework, okay? Y equals c e to the kt. Now, the given information is a little bit different. We do have 10 grams, though, right? To start with, which is c. So we do know that y equals 10 e to the kt. that we know. 10 grams, that is our initial amount, which is going to equal C. Okay. Well, now I need to use that half-life information. Okay. Hi.
Hi.
Nice to see you again.
Thank you.
Caught on this
No, that-
guard.
She was so. I think I caught her off guard. What do you think?
did.
She did come in earlier though, right? Like in the... Hi, Anthony. We're taking some guided notes, and there are extra copies in that green folder, and use it and I'll take it over. Okay. All right. So we know that this will decay to half of the amount in 24,360 years. It doesn't even matter how much you started with. Half of it will be gone in this amount of time. So what we're going to do, how much should we start with? Okay. In 24,360 years, how much are we going to have left? 5. Okay. Now I hear lots of talking, and this next step, I really need you to hear me, okay? It wouldn't even matter if we knew that they started out with 10 grams. If we are talking about half-life, if we take Y and we divide C over, it is always going to be 1/2. We don't even need the amounts to know that, okay? Okay. Same thing if you knew something like 10% of it was left. Well, then you know that that division would give you a 1/10. Okay. 90% of it is left. That division would give you 9/10, etc., etc. Okay. What?
It's a very long time for it to decay.
I know, right? Like, how do they measure that? Doesn't it make you wonder that sometimes?
Yeah.
Okay, so go ahead and in your calculator, let's figure this out. So we have e to the power equals 1/2. So the natural log of 1/2 equals 24,360K. What is K? So is it like negative 2.845 times 10 to the negative fifth, something like that?
Yeah.
Okay, my suggestion to you, keep that in your calculator. Just keep it there, right? Don't do anything yet. We've written it down, but don't ever go back and type it back in, okay? Let's go ahead and set up what we need to find. We are trying to find how long means we're looking for time. How long will it take to decay to 1 gram? So when we go over here to this equation, and we know what K is, what are we plugging 1 into? Y, that's the amount. So we want to know when we're reaching 1 gram. Okay, and I'm just going to write KT. We know it, but I don't really want to write that big decimal out. Is that okay? Okay. So we know 1 equals 10 e to the KT. So 1/10 equals e to the KT. If we're solving for t, we know we're going to have to rearrange. So the natural log of 1/10 would equal KT. So my suggestion to you would be in your calculator, type in the natural log of 1/10, close your parentheses, and then divide by K, which is already in your calculator. So those of you who just put it in your calculator, you can type in the natural log of 1/10, close your parentheses, and divide by second answer. And so then you don't have to pull it back up. Those of you who have the capability of arrowing up, you could arrow up and select it. But I know my TI-83s and the older TI-84s don't do that.
How do you do the arrow up? Do you just arrow to it and do the answer?
Yep. So if you
So if
Yeah.
I wanted to divide
so yeah go.
answer divided by.
I have that. I just don't know how to say that. 0.1.
Well, what I would do.
Well, it's about 16% of the year, so it's a little over a month.
So like 80,000
Divided by a little over here and hit enter and it brings it down.
Oh, that's cool.
Here, I'll figure out.
All right, what do we get?
It is 61 days and 32 hours. So a little over 2 months.
What is the answer?
Oh, what?
80,000 years, 920. Wait, 80,922 years and like 2 months.
22.168. But it's just a little over 2 months.
So during the 80,923rd year, it would finally reach half life, or 1 gram. Okay. Are you getting that in your calculator? Are you getting that in your calculator? If you're not practicing this in your calculator, you're not doing yourself any favors. Are we good in our calculators? I'm going to be obnoxious until I get confirmation.
Yes.
Okay.
Yes.
Okay. Last example, you ready? We're going to even have extra time to start our homework.
Only if you turn on the game.
That's the only way it'll work.
Yes.
Well, it's a good thing I like basketball. It's not what I want. Okay, read example 3.
What's crazy?
I think a plan. I totally picked that up. I was gonna say, if you know that,
I'll
look it up.
figure it out.
It's probably like a bug. It's a group of plants.
It is
So
a
like
group
The
of plants in the,
family. I told you it was a plant.
the pea.
Okay. So these weeds are taking over, right? The rate at which acreage is being consumed is proportional to the number of acres already consumed. What is that telling us? Okay, that's telling us dy dt equals ky, which implies y equals c e to the kt. Woohoo, our calculus is done. Okay, doesn't that feel good? Now, they give us data points.
So it's kind of like the first
It's kind of like the first one, but what did they not give us?
0.
So there are 2 acres consumed when time is 1. And there are 3 acres consumed when time is 5. We need to figure out both C and K so that we can plug in T equals 8 to get a Y value. So our goal is to solve for C and K. So it looks like we have 2 equations with 2 unknowns.
So you solve for one of them, plug in the equation for the other.
Okay, so Grace is suggesting we solve for one of them and plug it into the other one. So let's pick a variable. Should we solve for C or K? C. Let's solve for C. I think that would be a wise decision. Anybody care what we pick? Okay. I'm going to suggest you pick the smaller one. Okay? So let's go ahead and divide this over. So in this case, C equals 2 divided by e to the 1k. And we can come over here to equation number 2 and plug that in. So 3 equals C times e to the 5k. Okay, so what's happening is this 2 is being multiplied by the e to the 5k, and all of it's being divided by e to the 1k. So we can combine those together to be e to the 4k because we would subtract our exponents when we divide. Do you have any questions about what we just did? So now we can divide by 2. And if we're going to solve for k, we're going to have to rewrite this as the natural log of 3/2 equals 4k. So we have the natural log of 3/2, and then that value needs to be divided by 4. This, no, 16. February? It was like that week of Valentine's Day, wasn't it? Or after Valentine's Day? Yes, because Valentine's Day was on a Thursday, so the 21st. Okay, so what did we type in? We typed in the natural log of 3/2, and then we divided that by 4. Okay, so I'm going to keep that there. But what was it? It was 0.101366. Okay. So then I'm going to come over here. And in order to figure out C, we already solved for C here. We can plug our K value in. So watch what I do in my calculator. I'm going to take 2 divided by e to the K, but instead of typing that in, you can either hit second answer, or those of you who can arrow up and choose it. Okay, so there's our C value. I'm just trying to help you not to have to type in a bunch of stuff. Okay. So C was 1.8072, blah, 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 blah. Okay. In our calculator, we have C. In our calculator, we have K. So now if we want the amount at time equals 8, then we can go in our calculator and we can say, oops, this was our C value. So I'm just going to arrow up times e to the K times 8. Is that answer on it? Hey, there it is. If this were not multiple choice, I would expect you to label this answer 4.066 acres because the amount is labeled in acres. We are in here until 11:35. Can you promise that you will work on one of your assignments until 11:35?
Yes.
Okay. You have 2 assignments. So the more you can get done in here, the less you'll have to do tonight. So you can either go back to the one you started on, page 421, or if you want to try a couple of these before you go, you can try something from page 412.